Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 9th grade topic, solving linear equations review. Now, if you're new to my channel, I put timecodes in for this video in the description box below, so use it to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today or even your own homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 9th grade playlist, in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is going to have 2 parts, so leave a like, smash the subscribe button, and let's get started. So today we're going to be covering how to solve linear equations. Now, technically, I've already given you a video on this topic for this channel. However, that was a longer video and I want to give you a more compact review to give you a quick refresher if you need one. But if you want to see the longer one, no worries, I'll put it right up here or even in the description box below. Now, when solving your linear equations, the goal is to find the value of your variable that works for the equation. So if I gave you something like 3 plus x equals 5, the goal is to find what value of x makes this true. However, this is very simple. You can kind of look at this and tell that x has to be 2. X has to be 2. There's no other x in here that's going to make this work. But not all linear equations look this simple. We have much more complicated looking ones, although not actually complicated, but they're more complicated looking. So let's say we have 7 equals x minus 8 all over 3. And we want to solve this linear equation. Now, we know this is linear, although it doesn't look like one, because the power here, or the exponent is 1. It's an understood 1. That means you have a linear equation. So we are technically solving a linear equation. Now, what do we want to do? What's our goal for solving this? What we strive for is to get your variable on one side and only that variable be on that side. That means everything else, all your other constants, are going to be on the other side. It doesn't matter which side you pick, just pick a side. So since x is on the right side of my equal sign, I'm going to keep it here. And I'm going to get all the constants on the other side. So we see we have 7 equals this fraction. We don't really like fractions. This makes things a little bit more complicated. So I want to kind of get rid of this fraction first, because what I want, our x, is actually in the numerator here, and we can easily remove this fraction by multiplying this side by 3. Because all of this, x minus 8, is over 3, is divided by 3, we can multiply by 3. And whatever you do to one side, remember you have to do to the other side. You have to keep them balanced. It equals. So we rewrite this as 21 equals, that goes away because you're dividing by 3 and multiplying by 3, x minus 8. Now we have no more fractions. We still want to get x by itself. I chose the right side, so I need to get all my constants to the left side. How do I get rid of this negative 8? Let's add 8 to it. And whatever you do to one side, you do to the other side. So we have 8 plus 21 gives you 29. These go away, which leaves you with an x. Now we have, if you want to rewrite this as x equals 29, a value for our variable. But we're not done. You should always check your work. So let's plug it into our original. If you recall, it was 7 equals, let's draw a line here, 7 equals x minus 8 over 3. Plug in x equals 29 right in here, and we want to make sure that this right side equals 7. This 7 shouldn't be changing. This whole thing here should equal 7. So we have 29 minus 8 over 3. 7 equals 21 over 3. And 7 equals 7. Checks out. This means that our value that we found is actually going to be the correct one. This is how we're going to solve our linear equation when it looks like this. But let's move on to a slightly more complicated looking one. Let's say we have a linear equation that looks like this. 7 times, in parentheses, 6 minus 2a equals 5 times, in parentheses, negative 3a plus 1. Now, we know this is linear because once again, what is the exponent on these a's? They are an understood 1 linear equation. But there's an a on both sides. If our goal is to get a on one side because that's our variable, how do we do that if they exist on both sides? Well, we want to make them end up eventually on one side. So we're going to do all of our math like we would normally do, but try to make sure anywhere we can get all your variables, in this case all your a's, on one side and all of your other things, your constants, on the other. We're not changing up how we solve this. That's what we're trying to strive for, so that's what we have to do. Now, let's get rid of some of these parentheses because we can't really do much work with these parentheses here. Let's distribute what we can. So it's going to be 7 times our 6 gives you a 42 minus this 2a, so 7 times that 2a gives you a 14, a negative 14a. 5 times this negative 3a gives you a negative 15a. And we have a 5 times that 5, so plus 5. Now we have no more parentheses. So you have to pick a side. I'm going to pick the right side. All of my variables, or my a's in this case, are going to be on the right, and all my constants, once again, are going to be on the left. So I'm going to have a 42, and it's going to be minus 14a. I want to get everything that's a variable on this side. So I need to cancel this out. So you're going to be adding 14a. All right, I'm going to keep a space here. 15a plus 5. And I want to also get rid of this constant. So I'm a minus 5 from this side. So we've added 14a to this side, and we've subtracted 5 from this side. But whatever you do to one side, you have to do to the other side. So if I'm going to add 14a here, I have to add 14a here. If I'm going to subtract 5 here, I have to subtract 5 here. So this is what you started with. And this cancels that. This cancels that. And this is just you being consistent on both sides. Now, you've canceled these out effectively. You're left with 42 minus 5 equals 15a, sorry, it's a negative 15a plus 14a, which gives you a 37 equals negative a. Now you may think you're done here, but you aren't. We want to find the value of our variable, not our negative variable. So we want to multiply both sides by a negative 1 so we can flip the sign, which means our actual answer, a equals negative 37. So now we've solved our linear equation, or at least we think we have. We still need to check our work. So let's say a equals negative 37 up here, and we're going to start back up here, plugging in our a and see if both sides eventually equal. Anytime you have the time, make sure you check your work. Don't just assume that you did all the math correctly, because you could be pretty far off if you've made one mistake. So let's plug in everywhere we see an a. So I'm going to get rid of this so we don't confuse ourselves. Everywhere you see an a, we're going to put in negative 37. So 7 times 6 minus 2 times negative 37 equals 5 times negative 3 times negative 37 plus 1. Let's work inside the parentheses first before we start dropping things. So we're still going to keep that 7 on the outside. 6 minus what's negative 2 times a negative 37. What's actually going to make it a positive, and it's going to be 74. All right. So we have 7 times 6 plus 74. We can drop the inside parentheses. Now we're going to have 5 on the outside. Let's focus on inside the parentheses. We have negative 3 times a negative 37. What's that going to be? That's going to be a positive 111 plus 1. Now let's distribute like we did before. That's going to be 42, 7 times 6, and then you're going to have 7 times 74, which is going to give you a 518. Now we have 5 times all of this, so it's going to be 5 plus 5. Distribute your 5. Now we want to add both sides to see what we get. So 42 plus 518, let's add everything on this side. That's going to give you a 560 equals 555 plus 5 gives you a 560. Seems like it checks out. That means that A is indeed our variable that solves this linear equation. So whenever you have variables on both sides, your same variable on both sides, you want to still pick a side and get all of them on one side, and then get all the other constants on the other. So I hope you were able to follow along with his video, and I hope you got a nice quick refresher on how to solve your linear equations. However, if you have any questions about what you saw today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, hit that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I'm really hoping it's helped with your homework, and look forward to seeing you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Senpai.